Lesson 8-8 is about finding angles in polygons. In order to find angles in polygons, we need to remember a very important fact. And this fact you might have learned last year in 6th grade. And that is that if you were to add up all the angles, all three angles in any triangle, you're going to always get 180 degrees, no matter the size or shape of the triangle. If you add these three angles up, you're going to get 180 degrees. And also, the nice thing about that is to find the missing angle, you're going to add the two angles that you know and then subtract them from 180. In other words, subtract the sum of the two given angles from 180. Let's try example number 1 with the triangle MLN. You'll notice that I know two angles, 57 degrees and 74 degrees. I don't know the question mark, so I'm going to put a little X there saying I don't know that. Now, what I know is that all of these angles are going to add up to 180 degrees. Since we just finished equations, let's go ahead and set up an equation. That means that X, whatever that is, plus 57 degrees plus 74 degrees equals 180. I need to figure out what that unknown is, and if you remember back to our solving equations, especially when we have to combine like terms, our first step is to go ahead and add up our like terms. In this case, 57 degrees and 74 degrees are our two known angles, so we're going to add those together first. Let's see, 57 plus 74 should be 131. All right, so I know that some angle, whatever it is, x, plus 131 degrees, will give me 180. Well, this is a one-step equation, so I'm going to subtract 131 from both sides. So x is equal to whatever 180 minus 131 is. And in that case, that would be 49 degrees. What you could have done, instead of setting up the equation, which go for it if that makes sense, is to go ahead and add 57 plus 74 and then subtract it from 180. I like the equation because it makes it very clear what I need to do. If I follow my rules of solving equations, it shows me, well, hey, I got to combine my like terms first to get to 131, and then I'm going to subtract 131 from 180. It just takes the guesswork out of it. Let's do example 4 together, and then I want you to try 5 and 6 on your own. We'll check it at the beginning of class tomorrow, so make sure if you want complete points for your notes that you have number 5 and number 6 done. Okay, so I have two angles that I know. Angle D is 47 degrees and angle F is 30 degrees. Remember, I know that all three of those angles in the triangle have to add up to 180. And this time for the question mark, instead of using X, I'm going to use M because it's okay to use any variable. I don't want you to get used to only using X. I'm going to set up my equation. Angle M plus 47 degrees plus 30 degrees is equal to 180 degrees. All triangles have 180 degrees, so I know that all three angles have to add up to 180. I'm going to add my like terms together. M plus 77 degrees equals 180. This is a one-step equation, so to solve for M, I'm going to subtract 77 degrees from both sides. And I get M, sorry, I almost wrote an X. M is equal to 103 degrees. One thing I forgot to mention is, remember, one of the beautiful things about equations is that you can check. If 103 degrees is the right answer, then 103 plus 47 plus 30 would add up to 180. Let's go ahead and check it real quick. Because who doesn't like getting 100% on their tests? 103 plus 47 plus 30. Add them up, and look, 180 degrees. So I know that 103 is the correct answer. Okay, go ahead and do number 5 and number 6 on your own. We'll check them in class. Okay, since we know that triangles have 180 degrees inside of them, all 3 of those angles add up to 180, we can use that knowledge to figure out how the sum of interior angles of any polygon, any shape. And what I mean by sum of interior angles means, like if I look at this quadrilateral down here on number 11, if I took this angle plus this angle, plus this angle, plus this angle, I'm going to figure out how many degrees are inside of it. And I can do that by breaking it up into triangles. But you have to be very specific on how you break them up. Let's look at number 7. We're going to focus on this quadrilateral here, which remember quadrilateral means 4 sides. To break it up into triangles, you're going to connect one vertex to another. And vertex, remember, is just a fancy word for the corners. Okay, so in their example, they connected the opposite vertexes here. Now, you could have gone from here to here as well if you wanted to. But this is something very important. You cannot do both. Do you see how I have 2 diagonals inside this kite that actually intersect? That's a big no-no as far as finding the sum of the interior angles. Because when you have this line here, you're actually double counting. This triangle and this triangle are a part of the bigger triangle. So there's no need for that extra line. Just remember, diagonals inside of your polygons cannot cross. All right. When they've done that, you know that there are 2 triangles inside of the quadrilateral. Pentagon, so 1, 2, 3, 4, 5, that's my pentagon. If I am connecting sides that are opposite and I'm not having my diagonals cross, I'm going to choose one point. I'm going to start here and I'm going to connect the vertices that I can without crossing. So I form 1, 2, 3 sides, or 3 triangles. And hexagon has 6 sides, and I'm able to, without crossing, form 1, 2, 3, 4 triangles on the inside. What do you notice between the number of sides on my shape and the number of triangles that I can form on the inside of that shape? Well, if you said that the number of triangles is always 2 less than the number of sides of the figure, you're doing well. 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 2 is 4. So that's how we know that if I have a 4-sided shape, I'm going to be able to form 2 triangles. If I had a 6-sided shape, I'm going to be able to form 4 triangles on the inside. Well, pretend I had a decagon. A decagon has 10 sides. So how many triangles will I be able to form? And that'd be 8, because 10 minus 2 is 8. This is really important because you can use the number of sides to find out how many triangles you can form on the inside of your polygon. And the reason that's so important is because each triangle has 180 degrees on the inside. So let's focus on this quadrilateral here. I have 180 degrees in that top triangle, 180 degrees in the bottom triangle. So the 2 triangles that make up this entire quadrilateral would add up to 180 plus 180, which is 360 degrees. It means all quadrilaterals, no matter their shape or size or anything, will have 360 degrees. Pentagon will form 3 triangles, so 180, 180, 180. So to find the total sum of the interior angles of every single stinking pentagon, no matter the shape, I would take 3 times 180, which would be 540 degrees. hexagons, I can form 4 triangles. So 180, 180, 180, 180. So that would be 4 times 180 degrees, which is, I believe, 720 degrees. That means every single stinking hexagon is going to have 720 degrees inside. All of those angles are going to add up to 720 degrees. There is a formula to figure this out, and it uses the letter N for the number of sides. Now you're going to use the number of sides to find out how many triangles are going to be on the inside of that shape. And remember, we said that the number of triangles is always 2 less than the number of sides of the figure. I'm going to write that down as n minus 2. My first step is to find the number of sides, subtract that by 2 to figure out how many triangles are going to be in my polygon. Once I do that, I'm going to multiply it by 180 degrees. This portion, the n minus 2, finds out how many triangles my polygon will have, and then I will multiply it by 180, just like I did here and here and here. The 2 was found by taking 4 minus 2, which gave me my 2 triangles, times 180. The 4 was found by the 4 triangles that are formed in this 6-sided figure, times 180. And the 3 was found by taking 5 from the 5 sides minus 2, which forms my 3 triangles, times 180. Let's do number 12 together, and then I want you to do number 11 and 13 on your own. Okay, number 12, the key here, if you want to break it up into triangles, go ahead. Pick a spot that you're going to start with. So I'm going to start right here in this corner, and I'm going to go to every corner, every vertex that is not already connected by one of the sides. Now you can break it up like that. That works. None of my diagonals cross. And I'm going from vertex to vertex, not vertex to edge. Or you could have it broken up like so. There's all sorts of different ways to do this. So I am able to form 1, 2, 3, 4 triangles. So 180 degrees times 4 is 720 degrees. Let's think back to the formula. How many sides are in this shape? 1, 2, 3, 4, 5, 6. So there are 6 sides, and we use n for the number of sides. To find this using the formula, I would need to take 6 minus 2 times 180, or 4 times 180, which is the same thing as what I did right here. It's just that it's flip-flopped, and that's okay with the commutative property. Okay, that does it for this video. I want you to do number 11 and 13 for tomorrow. Good luck.